Okay, today we are going to talk about the discriminant. Our learning intention is to have an awareness of the discriminant and how it's used. Some of the success criteria is being able to record the quadratic formula. Recall that the discriminant is the part of the quadratic formula which is b squared minus 4ac. So that part is the discriminant. And also then use the discriminant to determine the roots of any quadratic. Okay, so for example, here's some important information. The discriminant, these are the solutions of a quadratic equation, and they are also called its roots. So if we were to do it graphically, we're looking at the x-intercepts. So algebraically, they're called roots. Graphically, they'll represent the x-intercepts of the quadratic. The quadratic formula can be used to calculate the roots, and if we remember it, x squared equals minus b plus square root plus minus square root of b squared minus 4ac over 2a. And that's where you get those b, a, and c from the general form of ax squared plus bx plus c. Okay. So this part here, so anything that's underneath the square root sign, that is the discriminant. Yeah, so we've seen it before. So if that equals or is greater than 0, then there are two real roots. So if the discriminant is perfect squares, such as the square root of 49 or the square root of 81 plus or minus, then the roots will be irrational. So that will be like plus or minus 7 and plus or minus 9. If the discriminant is not perfect, so if you get something, say, for example, square root 48, then the roots are irrational. Okay. If the discriminant is 0, then there are two equal roots. So if you get square root of 0, then there'll be two roots where they'll be equal. And if the discriminant is less than 0, so for example, negative 11, then there's no real roots, because we can't get a square root of a negative number. Let's do some examples. Okay, we'll do example 1 first. Okay, we're going to find the discriminant and state whether the roots are real or not real. We've got this one first. We've got x squared plus 4x plus 4. If we use the discriminant formula, we've got b squared minus 4ac. Plug in what we know. That's our b value, that's our a value, and that's our c value. So 4 squared minus 4 lots of 1 times 4, well, that's just 16 minus 16, which is 0. And using our rules, discriminant equals 0, so then there are two equal rational roots. So therefore, as discriminant equals 0, there are two equal rational roots. And we can see that because if we factorize x squared plus 4x plus 4, that is x plus 2 all squared. Yeah. So that means that the x-intercept happens at negative 2. And so we get this graph here's your negative 2 value, and you get this parabola, that's 4, at negative 2. And that's why we have this double root, or the two equal roots which are rational. Okay. Let's do the next example. We've got y equals x squared minus 3x plus 5 using the discriminant formula. Yeah. That's negative 3 squared, which will become 9, minus 4 lots of 1 times 5. Well, that's going to be 20. That's going to give us a negative 11. So the discriminant is less than 0, so there are no real roots. And so what that means is if we were to graph this, you'd have if x was 0, it would be up here at 5. Let's say x was 1, 1 squared minus 3 is minus 2, plus 5 is 3, so 1 is 3. Then we've got 4 minus 6 is minus 2, plus 5 we've got, yep, so we've got something that looks, just doing it quickly, looks something like that. And as you can see, it doesn't cross the x-axis, so there's no real roots. And that's why we get a negative number underneath as a discriminant, or underneath that square root sign for the quadratic formula. Okay. Question C, part C. F of x equals 3x squared plus 6x minus 2. Once again, using the discriminant formula. B becomes 6 squared, and that's going to be 36, minus 4 lots of 3 minus 2, that's minus 12, plus 24, which will be 60. Okay, so 60 is not a perfect square, and so therefore the discriminant is greater than or equal to 0, but not a perfect square, which means the roots are irrational. So if we were to do square root 60, that's the same as 4 lots of 15. 4 is a square, which is 215. So we have plus or minus 2 square root 15 as our roots. Okay. Next section, next example. Right. We're going to prove that 3x squared minus x plus 7 is greater than 0 for all real x. And basically what that's meaning, if we had a Cartesian plane, we're saying that this quadratic falls into this section, yeah, when y is greater than 0. That's what it's saying. So it's going to fall somewhere here, which means that it shouldn't have any x-intercepts. So if that's the case, the discriminant is going to be less than 0. I'm going to test it by using the formula. Okay, so we've got negative 1 squared minus 4 lots of 3, which is our A, and 7, which is our C. So we got 1 minus 84, which is going to be negative 83. And so the discriminant is less than 0. So currently, as discriminant is less than 0, there are no real roots for 3x squared minus x plus 7. Okay, and we can do it by just let's test some values, or let's plug some points in. So if it was 0, this whole thing would be 7. Okay, so up here it's just a sketch, would be 7. Okay, if it was 1, 3 minus 1 is minus 2, so 3 minus 1 is 2, plus 7 is 9, 3 plus 1 is 4, plus 7 is 11, and this is 17, and this is 21. Alright, so we've got 7, we've got 9, 17, 11, and 2, so it looks something like that. And as you can see, the parabola is above y equals 0 and does not cross the x-axis. So just to recall our success criteria, we need to be able to remember what the quadratic formula is. Recall that the discriminant is b squared minus 4ac, and that will tell us the types of roots, if there are any. So if it's greater or equal to 0, there are 2 roots. If it's a perfect square, the roots will be rational. If it's not a perfect square, then the roots are irrational. Discriminant of equals 0 is 2 equal roots. Anything less than 0, that means there's no equal roots. So thank you.